And we should be good to go. All right. Wow, small class today. All right. Well, number of things I want to go through today. I want to look at the previous ODP and the current ODP. And particularly the previous one, there were some issues people were running into with that. So I want to look at some of the possible pitfalls on that assignment. And then look at any questions on PA4, run through the sample high-low program and make a few comments on that, and then talk about PA5. And then we'll work our way back to talking more about regular expressions. So let's begin with any questions anybody has first.
I have a question on the high-low program.
Okay.
I'm encountering an issue where when I have it read in the user's input for the keystroke, it isn't really like it's saving the value. I'm getting it to read out as what the user input by testing it with an echo statement, but it's just defaulting to like no matter what I like test it again. So like if I say like, you know, value of user, if the value of user input equals literally anything, it doesn't matter what the user types or what that value is. It just goes down that branch.
All right. First question, are you using double equal signs in your comparison?
No, I'm using dash equals.
Okay, so dash EQ is for comparing numbers. And so if you have something like the letter L or the letter H, when you treat that as a number, it gets treated as 0. So double equal will compare strings, and then it just looks character by character. So try changing that, and I bet you it'll work well.
Perfect. Thank you.
Yeah, you're welcome. Yeah, what someone just said in chat. That's perfect. Cool. Other questions? So how's PA4? People pretty much got a handle on that? Okay, cool. All right. Well, let's take a look at ODP 418 and let's dig into some of the details of that. Yeah, go ahead.
I just had a random question. How can
Okay.
Is there a way to, is there like a simple command to see which files you've uploaded to Git?
So I mean, you can, the most direct way would be to hop onto the GitLab website and look in the repository. But you've got some other options as well. So you can go into somewhere outside your CSE224 directory, right? Just go, go into your home directory and, make a temporary directory so that you're not doing anything at all with your 224. And you can do the following command: git clone git at gitlab.com colon whatever your username is at GitLab. So your git ID /CSE224.git. And if you do this, it will create under this directory a subdirectory called CSE224, which will be an exact copy of your entire repository. And you can hop into there and see exactly, what's been pushed to your repo. And that's a direct way without having to go into the website. But there's other things you can do. So if you're in a directory, you can say git status. So let's do this. Let me just hop onto a machine I have. So if I say git status, it'll show me I have some files that I've modified but not yet added to Git. I have some files that are listed as not being under Git control. I haven't added them yet. These are files that I've modified but not yet added. And so Git status gives you a pretty good quick view of the state of your different files. You can also say git log and see all of your commit messages, but if you don't write good commit messages, which I've been told some people don't, then this doesn't give you a lot of information. But git log, git status are two quick measures you can use.
So git status basically just tells you which files are not on Git.
It will tell you pretty much everything. So if I'm all up to date, it'll say, I have one file that's been modified but not added. No changes added to commit, that kind of thing. So yeah, mostly it'll tell you if there's things that aren't on Git. But if everything is up to date, it should just say some nice satisfying message like nothing to commit, working tree clean. So that's your happy message. All right, good. Other questions?
So I have one that's kind of an abstract question, I guess you could call it.
Okay.
So the display command, or whatever the command was that allows the GUI.
Yeah, dialogue.
Dialogue, yeah. I was like, one of those, display GUI.
Yeah.
But so it's like, I'm like curious sort of like how that actually works. But is that like really complicated? Or is it like just extreme quantities of like C with printf statements?
It's a lot of effectively printf statements. So let's hop on the server. Let's do a quick dialogue. All right, so there's our dialogue. Let me change my colors to the non-verifying version. So if I run this and I send my output into a file, these are the characters that are being printed by the dialogue command. And so there's a really old terminal that's called a VT100. It was made by Digital Equipment Corporation. It was really the terminal everybody used following the VT52. And VT100, one of the things that it did was it understood certain sequences of characters, what are called escape sequences. So this caret left bracket, that's the way that VI shows you ASCII character 27, which is an escape. And so this is an escape followed by a left bracket, a question mark 1049H. And VT100s, if they were asked to display a sequence of characters that included an escape character, they would do something different. And so, for example, if you got an escape bracket, I think the letter C, it would clear the screen. And different escape sequences could change colors. They could make text bold. They could make text blink. They could also use an alternate character set that included little pieces of lines. So things that might look like this, or this, or this, and so on. And if you draw these symbols in the right way, you can make things that look basically like pictures. So like this. And so even though VT100s don't really exist anymore, PuTTY and my console program here, console with a K, and most other terminal emulators still understand VT100 control sequences. And so Dialog is just taking advantage of that and basically controlling the display to say, hey, you know, make the background blue and go to these coordinates and draw this little symbol and so on and so forth. And these escape bracket number semicolon number H are, I believe, cursor movements. And so this is just, you know, drawing a picture out of little individual pieces. And the steam locomotive program does the same thing, right? So I can run SL and send that into a file. And it's got some delays in it, so it takes a little while. But if I look in that file, same thing. It's just a bunch of these escape sequences, but a whole bunch of them to make the steam locomotive, 1,000 lines. All right, so Dialog does this, but it uses a package called ncurses. And ncurses is a library of functions you can call in C that know how to use these VT100 escape sequences. And so if you want to write something like Dialog, you don't have to actually know send an escape bracket, blah, 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 right? So there's functions you can call to do things such as, you know, move to this XY coordinate, draw this string, or draw a box with these dimensions at this location, and so on and so forth. So yeah, it's a bunch of C code, but it's not as terrifying to write as it might seem, because we've got this curses package. And this is the same package that's used by Rogue. So the code for Rogue is really just built on top of that. And so on. I got a Kestrel chasing me. There we go. And we have a top 10 score now in CSE224 for this year, so good job. Can we figure out how to shoot a bow? So good question. So if you type a question mark, it'll say what characters you want help for. Type a star, and so you can zap a wand with Z. You can throw. I think you use a bow if you find it. Bows are hard to find, but either try wielding it with a W or yeah, I would try wielding it. And then just do an HJKL to indicate a direction. Give that a shot. All right, so does that make a little bit of sense about control sequences? And so this was a steam locomotive file, right? If I cat it, you can kind of see the train go by really fast, but it's pretty quick. So the SL command actually puts delays during the output process. Or I could do something really goofy and run it through more. Get that kind of thing. All right, other questions? Ignore that. All right, let's look at ODP 418. So this was writing a C function called move that should basically take the first character of a string and move it to the end of the string. And it's a pretty simple thing to describe, but it can be surprisingly tricky to get just right. And so let's look at this. So start with some simpler examples. So HELLO. And if we're dealing with strings, we want to remember there's a null terminator on the end. And I like to write down some useful facts. So string length of this string is going to come back as 5 because string length tells you how many non-null terminator characters there are. It doesn't count the \0 though.
Does it count characters after the null terminator?
It does not. So C considers your string to end right here. And it knows that because of the null terminator. And so everything after that completely ignored. So index wise, we always start from index through 0. And the last character has index 4, which is also index string len -1. All right. So what we want is we want to make a new string, ELLOH, still followed by a null terminator. And again, bracket 0 through bracket 4, and the null terminator is bracket 5. So there's a few steps to this, right? First thing is, shift characters down. And what we want to do is copy from position 1 into position 0. Copy from 2 to 1. Copy from 3 to 2. And copy from 4 to 3. So the last one will take the O and copy it from there to here. And then we want to take this first letter and copy it to the last position. So something like index string length -1 should be copied from 0. And then we want to copy the null terminator. And so index string length should get copied from index string length, or just a \0. So you got to do all three things in general. And so this is a for loop, and we can go from 0 up to string length -1. So we can do something like this. For I equals 0, I less than or equal to string length -2, I plus, out bracket I equals in bracket I +1. All right, so are the bounds here correct? This is a hard question. So look at our example, string length is 5. This would say I starts from 0 and should be less than or equal to 3. And we're going to copy from I plus 1 to I. So the last statement in this loop would copy from 4 into 3. That is the last copy that we want to have happen in this shift section of our code. Now, if I go up to string length minus 1, or if I just say less than string length, I would also copy from 5 to 4, which would copy this null terminator into this position. That doesn't do any harm. It's just, it's going to get overwritten eventually. But that would still work. And then in the second part, we want to copy from input character 0 into, in this case, position 4, so string length minus 1. And then we want to set the null terminator. And that works great in the general case, but we've got to think about edge cases also. So one edge case is when your input is an empty string. And so if I do that, string length will be 0. So this for loop will definitely not do anything, so that's fine. But then when I copy from character 0, well, if I try to access character 0, that's going to be the null terminator. But I'm going to try to copy it to index minus 1. And that's a potentially strange thing to do. So I need a special case when my length is 0. And the other possible edge case is if my input has just a single character. So here string length is 1. So again, my loop will not do anything, which is fine. This will copy character 0 to character 0, that's fine. And then copy a null terminator to character 1, that should work fine. So that would make my output string an X followed by a null terminator. But this is still an edge case. And if that's our edge case, right, we can just return an empty string. So let's see. So this was the solution I coded. And I iterated over all the characters, which again, you don't need to do because I don't really need to copy that last one, but it does no harm. And then at the end of that loop, I go ahead and I just tack on a null terminator. So I will be equal to the string length at the end of this loop. And if our string length is 5, we want our null terminator to be at index 5. So that puts the null terminator in the correct place. And then if I was bigger than 0, I copy this first character in bracket 0 into out bracket I minus 1. So the spot right before the null terminator. So that takes this H and copies it into that spot right there. And if the length of the string is 0, I don't do that final copy, but I will still have done the following. I'll have done no iterations of this loop, right? Which means I will still be 0, and then out bracket I, out 0 will be the null terminator. And so I'll get a nice clean null terminated string. All right, so it's great to talk about this, and I can make it sound really easy from this side of having done it. But if you're trying to do this for the first time, it's not as easy, right? And there's a few problems. So the first problem is knowing that the code doesn't work. And you've got the assess command, and if you get 10 out of 10, you're fine. But if you don't, then the system's telling you, hey, there's a problem somewhere. So the next challenge is figuring out where is there a problem. So you got to find a test case that breaks your code. And this is hard. You can make a whole career out of just looking for test cases that break code. Now I suggested some cases. I suggested trying something like hello, and then trying a single letter, and then trying an empty string, and then trying, something with more than one character in it. And doing these in one main program so that you get the extra complication of having already called your function and seeing if it works on those cases. And if you're lucky, it will break. it will either seg fault or it will give you a plainly incorrect result. But if you're unlucky, it'll work, even though there's a bug somewhere. And in that case, your only real resort is to run through the code by hand. And this is actually, something you should probably be doing first. While you're thinking about the algorithm as you're writing the code, you should be pretending you're a computer and running through it by hand. So GDB is great, right? Someone just asked in chat, why not GDB? If you have a case that's failing, GDB is good, right? If you can write a main program and run it and it seg faults, or it says, ABCLO instead of ABC, go ahead and use GDB. But sometimes we don't have a good test program that makes our code fail. And there might still be a bug in the program, but it's not showing up under our test code. Or worse yet, sometimes we have code that fails, but when we run it in GDB, it starts working. And that's just super bonus frustrating. Because if your debug tool makes the bug go away, you can't use it. So your sort of final option, which is probably, something you should be doing anyway, is to go through the code by hand. And this is an exercise in pretending you're a computer and trying to do exactly what the program says should be done. And the challenge here is actually seeing the code as it's written, as opposed to seeing what you think the code is going to do, right? So it's the proofreading problem. You write an essay and you read through it to look for mistakes, and you don't actually read the words. You read what you wrote in your head. And so you missed, when you got 2 words transposed because you're not actually, seeing what's on the paper. So same thing happens with debugging. If I've got a section of code and I'm like, yeah, so this is going to copy all the characters and move them down one spot. If my index is wrong, I'm not going to see that unless I'm really, really kind of clearing my mind and thinking, okay, I am just a uninspired machine. I'm just going to do exactly what each of these statements says. And I'm not going to think about, big picture or anything like that. I'm just going to go statement by statement. And so that's challenging, but we can do that. So let's look at a sample piece of code here. So here's a an attempt at ODP 418. And so, save the length of the original string. If the length is 1, we'll just copy the first character and return. Otherwise, we'll do our loop to shift down, and then we'll copy the null terminator and return. And if you run this, with a couple of test cases, it works great. But if you try to assess it, it gives you 0 out of 10. So here's what we do. We pretend we're a computer. And to do this, you not only need to look at the code exactly as it's written, but you need to make sure you're not making any assumptions. So I'm given an array of characters. I'm returning an array of characters. If you don't know what a statement means, it should probably not be in your program, right? But maybe I don't understand the question.
Yeah, so basically I've ran into issues where I'm reading someone else's code.
Okay.
Like I'm trying to learn from reading someone else's code, and then I have like
Right.
no idea what the heck they are meaning because they're using like weird voodoo magic. I'm not sure what to call it there, but they're doing weird things.
Right. So yeah, so that's a separate challenge. And the strategy there is, first of all, to figure out what those statements do. And so, either look them up or write some test code and try to get a handle on that. Because if you don't know what the statement's supposed to do, this exercise doesn't really get you very far. But that's if you know what the program is supposed to do, that can be one way to come to an understanding of what the statement is doing. But yeah, if you encounter that, you can definitely ask me, and I can try to help with that. So let's try some test code. So we're going to have an output array of 100 characters, and we're going to say move, and we're going to say ABC, comma out. So when we come into this move function, two things are going to happen. There's going to be a local variable called original, and that's going to be set equal to, in this case, the string ABC. So it's going to be an A followed by a B, followed by a C, followed by an null terminator, followed by who knows what, whatever happens to be in memory. And we're going to be given a modified variable, and that's a pointer to a character, so it's a memory location, and at the place it points to, we have no earthly idea what's in that memory. So I'm just going to put in a bunch of question marks. All right, then we're going to say len equals string length original. So that's original. String length will count up to the null terminator. Len will be equal to 3. If len equals 1, well, that's not true, so we're not going to execute any of this. So we're going to go down to the else, and let me write out what the else statement is saying. It's saying for I equals 0, I is less than, and so length minus 1 will be 2, I plus plus. And inside there, it's going to say modified I equals original I plus 1. All right, so the first time through this loop, I is going to be equal to 0. This is going to copy original 1 to modified 0. So original 1 is B. Modified 0 is going to become a B. Top of the loop, I gets incremented to 1. 1 is less than 2. Modified 1 becomes original 2. 0, 1, 2, that's a C, goes into modified 1. Top of the loop, I gets incremented to 2. 2 is no longer less than 2. So our for loop is done. And then modified bracket, len minus 1, len is 3. So modified 2 is equal to original 0. And so that takes original 0 as an A, puts it into modified 2. There's an A. And then we return. So when we come back from our move function, what does our modified string look like? It looks like a B followed by a C, followed by an A, followed by who knows what. And that is not a valid 3-character string. Because if this next byte in memory contains the letter Q, then that's part of our string. And whatever this is another part of the string. And all of these question marks will be part of our string until we happen to stumble across a null terminator. So this code is simply not adding the null terminator to the end of the output string. But the problem is, if I run this, in test code, or I run it in GDB, there's a good chance that all these question marks might end up being zeros to begin with. And if this happens to be a 0 right here, hey, I come back and it's like, yeah, your new string is BCA. Looks like everything worked great. So by making sure I'm not assuming that these are zeros, but putting in question marks, I can see pretty easily, hey, this is not the string that I wanted to get back. What I really wanted was a BCA null terminator, and then I don't care what comes after that. And so if this works, then you can try it with a 1 character, and you can try it with 0 characters, and so on. Yeah, go ahead.
Yeah, so I'm just looking at this and I'm thinking, right? That brings up an interesting point wherein if your code works 50% of the time, it's more than likely got something to do with something like this going on, where it's it could be so, it could be not. It might just, you're getting lucky and it's working out. Are there general things you can notice where and there might be a ton of these. So if that's the case, just figure it out on your own. But there's like a few where it's like, if you're noticing this certain pattern is happening in errors, then it probably relates to something going wrong here. Or yeah.
So with C, right, this is why enterprises shy away from C, I think. With C, there's so many opportunities for these kinds of mistakes to happen. If you're running code and you're getting seg faults and you're doing anything with strings, a pretty quick go-to would be to look for strings that are uninitialized, or if you're creating strings that aren't being terminated properly, because this is probably the most common situation. And if I'm really unlucky, something that uses this string might just keep going until it runs into a section of memory that it can't access. And so that's just something that you learn to think could be a possibility, and you try to prevent. And more generally, if you're getting seg faults, there's a good chance that there's a null somewhere that shouldn't be null. For example, you're opening a file and you're not checking to see if the file pointer is null. And so if the file doesn't exist and you start trying to read from it, you'll get a seg fault because the file pointer will not be pointing to a valid location. And there's some things you can do. There's switches you can put on your compiler that will help do something better than just seg fault. If something goes wrong, we'll give you more information. But for the sake of learning how to program at this level, your best bet is really, work through these things the slow, painful way. And once you encounter something like this, right, you're much less likely to make that same kind of mistake in the future. Now, other languages like Java, for example, right, if I declare an integer and I don't initialize it, it won't even compile my code. It'll say, hey, this variable might not have been initialized. And so a lot of languages really kind of try to save you from yourself and look for, these kinds of potential issues. All right, so how about ODP 419? Any issues or worries about that? So this is the one where we've got a state variable and we're setting it with a put function and we're reading it with a get function.
So I guess I do have a question.
Okay.
So this is pretty quick. How do you even declare global? Like, I know in other coding languages, you just like put it outside of the main function in a sense.
Yep. That's all you got to do.
Okay.
So for putget.c, you're going to basically integer put, right? You're going to write your get function. So if I declare a variable up here before, my function declaration starts, if I say integer global var, as long as I don't declare the same variable inside here, if anywhere in this function I access global variable, it'll access this, and the same thing in here. Now, if for some reason I say int glovar inside these brackets, then when I try to access glovar, I'm not accessing that, I'm accessing a local version. But as long as I don't declare this again in any of these functions, both of these will access that same global variable. And so that's usually all you need to save and retrieve information.
So what do these two functions say inside of them? Could you just clarify?
So your goal is to take an argument from your put function and save it in a way that lets your get function retrieve it. So your put function just basically copies it into this global, and your get function just reads from the global and returns that value.
Okay, I think I got it. What do they specifically say though? Does that say int A through S, or am I totally misreading it?
So your put function is int put, it takes an integer, and your get function is int get, and it takes no arguments.
Okay, got it. Thank you.
Yeah. All right, other questions? So let me just clear up some last ambiguity on high-low. So if you just run high-low, you're playing the game between 1 and 100. And you don't want to make a guess until you ask the user to think of a number and hit a key when they're ready to play, right? Don't just start the game saying like, hi, think of a number, is it 50, right? So ask them to think of a number and say, hit a key when you have a number in mind. And then go ahead and start making the guesses, and if they're low or high, adjust your guesses and so on. Okay, that's the first thing. Second thing, if the person does not type an HL or a C, just ask them to type an HL or a C. Don't count this as one of your guesses. Don't change your guess. Just say, hey, you know, do an HL or a C. And then if that's correct, right, that was 2 guesses. All right, third thing, if I run your program with an argument, it will be a valid, positive, reasonable integer. For example, 1,000, which says, hey, think of a number between 1 and 1,000, and then start making your guesses. So don't worry about, you know, if the person does this, or 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 any of these other things, right? I'm not going to try to break your code like that. If I use an argument, it'll be a valid positive integer. And if I don't have an argument, then just go up to 100. And then some people are getting worried about this hit a key when you have a number in mind. If I hit an enter key, it does this. But if I hit, you know, a space bar, then my message comes out on the same line because, you know, I didn't hit an enter key. I'm not worried about that, right? If that bothers you, throw an echo statement in after you read their keystroke. And is your number 50? So if I type an H, right, just go ahead and do an echo statement after after you come back from the read to move down to a new line. Because if I say read -N1 answer, and the person types a letter, right, there's no echo there. And so whatever comes out next from your script will show out on the same line. So this is the echo of the H the user hit. Just make an echo statement, right? And just echo by itself will just put out an empty line, or you can, you know, echo a space like that. So format it how you like, and I'm not going to, you know, be picky about formatting, right? I mean, I want this to look basically like what you're seeing here. But other than that, I'm not too worried about it. All right, is that good? All right, so let's look at PA5. All right, so PA5, as I mentioned, it's a group assignment. You have the option of working in groups. You're not required to, but you can have groups up to 4 people. And this is going to be an appointment calendar program. So the basic setup is you want to write a bash program that somebody can run, and it will keep track of appointments that they have. And so people should be able to make an appointment, delete an appointment that they've already made, and look at appointments that are in the future. And we want this program to remember appointments from run to run. So you're going to save the appointment information in a file on the drive. And so I can run your program, and I can, you know, record a few appointments that are coming up next week, and then exit your program and come back later, run your program and say, show me my upcoming appointments. And it should remember all of those appointments that I made. And then I can go through and I can delete some appointments, I can add new appointments, and so on and so forth. All right, so big difference from other assignments we've done, right? There's not a whole lot of detail that I'm going to give you as to how you have to implement this, as to what it should look like, how you should design it. You get to make those decisions yourself. So I'm going to require certain behaviors, but it's totally up to you what the user experience is. All right, the other difference is you can work as a group up to 4 people total, which means, you know, you can work on the code together, you can talk about it, you can share the code, and so on and so forth. And then one person from the group submits the code, and everybody in the group gets the same grade. All right, mandatory requirements. So it's got to run on the Linux server, and it's got to use the dialog command to implement a graphical interface. And you need to do at least 3 things: be able to make an appointment on a given date, be able to look at all appointments that are upcoming, so the appointments in the future, today or later, and be able to delete an appointment. And you start your program from the command line, but that should pretty much be it, right? I don't want to have to sit at the command line prompt and type in, you know, a description of the appointment or something like that. Everything should be done through these graphical elements that are available in the dialog command. And you want to save your appointment information from run to run, which means you're going to probably use a file that you save on the drive that records the information appointment. And a suggestion for a simple format would be, for example, just to have each line of the file correspond to a new appointment. And for each line, you can have the date followed by a pipe. If you have a time, you can put a time in there followed by a pipe, and then a description of the appointment. And a single line with pipes separating those fields is pretty easy to process inside Bash, and we'll see how to do that. But that's one way to save your information. To make this work from run to run, if you're working in a group, you're going to want a shared file that different people in the group can work with. So on the server, under the temp directory, I've created a calendars directory. And you can create subdirectories under that. This is writable by everybody. And so underneath that directory, you can create your own directory for yourself or for your team, and then put your files in there. And then just access that using, you know, /temp /calendars. My super group. Main data.txt, or whatever you want to call it, right? So pick some group name, some name for your team, and make a directory under there. And then you can put your files in that directory. Now, I wouldn't put your source code in here, right? Because this is readable by the world. But for the actual calendar appointment file, you can go ahead and pop that in that directory under temp, and that should work well. If you're doing this by yourself, you don't have to do that, right? You can just go ahead and you know, use a file in your own directory. All right. So in addition to those 3 required features, you have to implement 3 additional features. And you can pick what you want those features to be, but here's some suggestions. The ability to edit an appointment. So you have to implement a delete option, but it might be nice to say, hey, that appointment that I made, I need to change the description of that. So some way to, pull up a previously made appointment and make changes to it. An ability to add a time for an appointment as well as a date. An ability to add an end date and time as well as a start date and time. A way to check for conflicts so that when somebody makes an appointment, it will see if that appointment overlaps any others. And if it does, say, hey, this is a conflict, is that okay? Instead of just looking at all appointments in the future, look at all appointments on a given date. Or look at all appointments in a given date range. So these are fairly low-hanging fruit. Editing an appointment might be a little trickier, but these are fairly straightforward changes, right? And my suggestion is kind of keep them in mind while you're developing the code so that you don't, box yourself into a corner. But if you've done any sort of reasonable approach to those mandatory requirements, these don't generally add a whole lot of complexity to your code.
Simple little question.
Yeah.
How does it know which day is today?
So we have a date command, which will tell us the
Figured
current
it would be
date.
something like that, but
Yeah.
it's not like you can
And-
say, oh, today is this date. What appointments are coming up? I guess that's
Right,
the-
yeah, so use the date command, and the date command has zillions of options, including a way to format the output. So you can do a plus sign followed by any of these specifications. So date plus %D tells me what the current day of the month is. Date plus %M is something different. M is the number of the month. Y is a 2-digit year. Uppercase Y is a 4-digit year. But there's tons of options in here. And part of what we're working in this assignment is being able to manipulate strings in Bash. And this is where regular expressions are going to come in, and where things like sed, which we'll talk about later today, are going to help. And really, if I can get my date out like this, I can break it into different pieces using various Bash commands. But there's also, options on date itself. All right, more ambitious options you could consider. So adding a reminder feature. So for example, when you first start your calendar program, it could look for any appointments listed for today or any appointments in the next, 2 hours, and print out or, display something in the beginning like upcoming appointments as just a reminder to you. You could add an alarm feature. So there's a utility called cron, which I've enabled on the server, and cron lets you schedule a script or a command to be run periodically. And so I could set up something that runs every hour as myself, and it could go through my list of appointments. And if there's an appointment coming up in the next hour, I could have it alert me. So for example, you can send messages to other users on the server. So here's Nick on the Linux server. And here's somebody else on the Linux server called Macias. And I can say, right, Nick. Hello, Nick. Or I can just say, right, Nick. And say, hello, Nick. And the user named Nick gets a message, pops up in the middle of what they're doing. And I could say something like, time for your appointment. And I can pipe that into write Nick. And suddenly this message shows up for Nick saying, hey, time for your appointment. So you could use this as like an alarm feature, right? And if cron runs your calendar program every hour, maybe with a switch on it called, check for appointments, it could do that. And if it finds it, it could send you a message saying, hey, time for your appointment. And by the way, this can be a pain, because by default, you can write to anybody that you want. And if somebody sends me a message while I'm in the middle of VI, right, it looks kind of freaky now. It doesn't change my file, but it messes up what's on my screen. So I can hit a Control-L to refresh. But if people start bombarding you with messages and you don't want that to happen, MESG space N turns off messaging. And then if somebody tries to write to you, they'll get a message. Oh, I didn't get a message. Huh. Normally it says messaging is turned off. But anyway, that happens silently. And then if you want to get messages, say MESGY, and you'll go back to getting messages. So that's just another option, right? Have an alarm feature. If you want to get really edgy, you could try exporting or importing your calendar to something like Google Calendar. So comma separated files, right? Files where you have fields separated by commas in between are a pretty useful way to move information around from one program to another. There's a .ical format that you could look into and see if you can export in that format, and so on. And these are just suggestions, right? If you decide to do any of these, you're good to go. If you have some different idea that you want to pursue, let me know, and I can give you, thumbs up or suggest some changes to it to make it doable for this assignment, and so on. So one of the things you want to do in your group or with yourself pretty early on is think about, what are these other features I want to do? And you got to do 3 of these. And then the grading rubric is pretty straightforward. If you can make an appointment, that's 20 points. If you can look at upcoming appointments, that's 20. If you can delete, that's 20. If it remembers your appointments from run to run, that's 10. And then each of your 3 additional features gets you 10 points. So 100 points total. All right, so groups of up to 4 people. It's totally up to you who you want to work with, how you want to structure your group. And you can work with people from the other section if you like. That's totally allowed, but you can only work with people taking the course, obviously. And I recommend, dividing the workload in some way that makes sense, but making sure that everybody understands all the different pieces of the assignment and the solution. And then details, right? Every bash file that makes up your project needs to have in the beginning a comment block listing the full name of each group member, right? This is required in order for each person to get credit. And so I'll probably look at, if there's more than one file, whatever the main file is, but make sure, if you have 3 bash files in your PA5, each of those has this block in the top. Use the full names. We have people in class with the same initials. We have people in the class with the same last name. So make sure you use full names in this attribution to make sure everyone gets credit. All right, submissions. So make a PA5 directory under 224 and push your code over to GitLab by the due date. But here's the trick. If there's 4 people in the group and there's 4 repositories that each have the code in them and that code does not match, right? Which one am I going to grade? I'm going to grade the first one I encounter. And if that's not the right one, that's a problem. So if you have 4 people in a group and you're all working on your code and you're all pushing it up under your own private 224 repository, 3 of you should have a do not grade file sitting in the PA4 or PA5 directory. And if I see a do not grade, I'll skip that repository. And 1 of you should have your code pushed to PA5 without a do not grade file. All right, it's that simple. So coordinate amongst yourselves which one of you is going to push over the code that you want graded, and that person should push the code over and not include a do not grade. Anybody else in the group that's got a PA5 directory, make sure there's a do not grade file. So I'll download all the repositories at the due date. Any directory that doesn't have a do not grade, I'm going to grade. And once I've graded code for your group, that's the grade. So coordinate this. And if that's not clear, let me know. All right, and then demonstrations. So demonstrations will be done the last week of the quarter, starting on Tuesday for us on the 29th. And basically your goal is just to show the class and me what your code does. So what I want you to do is start off, show all of the appointments that are in the future, add 1 appointment and show all appointments again so we can see that that got added to the calendar, add a 2nd appointment and show all the appointments to demonstrate that that got added. Yeah, I need to add more to this because my next steps got removed. So you're going to want to delete an appointment and then show that the appointment got deleted, and then show the additional features that you chose. So describe briefly what you did and then go through some manipulations to demonstrate those. You don't need to go through the code itself, but if there's some part of the code that stands out to you, if there was something that was particularly tricky or clever that you did, you're welcome to talk about that to the class and show us your code. And theoretically, we have over 30 people in this section. If everybody decided to work alone, that would be 30 presentations, which is going to be really tight. But guessing that, you know, most people are going to work in groups, we should be able to get through this in 2 classes. If not, we'll have to do something different. But plan on being ready to present to the class right in the beginning of class on that Tuesday. And I recommend, you know, doing a brief run through with your group on how you're going to present, who's going to show what, and so on and so forth. And it can be 1 person does the whole presentation. It can be, you know, everybody does part of it, or 2 people do the whole thing, or whatever. It's up to you. But we're going to want to do this as kind of quickly as possible to make sure everybody has a chance to show their code. All right, and then grading for receiving any grade at all. This code has to be submitted via Git by the deadline. It has to run on the Linux server, and it has to use the dialog command, and it has to be presented to the class. And then these criteria go in for the actual grade. And then the last comment I'll make is just, you know, start this early and try to have fun with it. It can be a pretty fun assignment to work on because, you know, it's graphical, it's quick satisfaction. It does something that, you know, you can easily explain to friends, and they can see that you're doing something really cool, right? And if you get anything working at all, if you just get the ability to, like, you know, look at a static list of appointments, that's pretty cool. And then as you keep adding more capabilities to it, right, it just gets to be a better and better program that's kind of fun. So you want to spend a little bit of time up front thinking about what you want to do, how you want to design it. You definitely want to spend some time playing with dialogue so you get an idea what sorts of things are possible. But have sort of an overall game plan before you start doing too much coding. And decide, you know, okay, so when we run the program, what's it going to do? Well, it's going to print a welcome message, and maybe it'll show you upcoming appointments to begin with. And then it'll give you a menu and say, what do you want to do? And you can say, you know, make an appointment, look at appointments, delete an appointment. And then, okay, you can work on deletion and I'll work on making a new appointment. And, you know, sort of strategize like that and then get into it. Now you have 2 weeks and a day for this. It's due 2 weeks from Friday. That's the day after Thanksgiving. So assuming you don't want to work on Thanksgiving, get it done before then. But you have until the usual Friday morning, 8 o'clock deadline. And as far as group work, you can always, you know, work through email or Discord or whatever, and, you know, email code back and forth to each other. That works fine. But if you want to play around with Git, this is a good opportunity to get a little further into Git. And one thing you can do is create a completely new repository outside of 224. Just make a whole new repository somewhere. Put, you know, some initial code in there or a README, and then hop onto GitLab and make your group members owners or maintainers of that project. So just like you added me as a reporter, you can add other people and actually make them owners so they have full control over the project. And then you can start sharing code through Git. And the main thing to know is that if you want to, you know, make a new file and push it over, it's the usual git add, git commit, git push. If you're a new member to the group, if somebody's already created the repository and you want to make a copy of it, your command is git clone. So go into an empty directory, right? Not in your 224, but go one level above where you want your working directory to be, and git clone git at gitlab.com colon whatever your git ID is / and whatever you call your repository. And this will create a subdirectory named repo. And you can do all of your, that should have all of the files that were in the repository. And from here, right, if you're the other member of the group, you can make files, do an add, do a commit, do a push. But the other command you want to know is if you're going to work on a repository that somebody else has made some changes to, before you start making changes of your own, do a git pull origin master. This is from the repository directory, and this will go to GitLab, find the files in that repository and pull them down so that your repo is now in sync with GitLab's repo, and therefore in sync with, you know, what your group member was doing. And then you can make some changes, git add, git commit, git push. And then when your partner comes along and wants to work on it, they do a git pull, and that'll pull down the changes that you made. And so you can coordinate like that. And if two people make different changes and haven't pulled down the other person's changes, and then they try to push those, then you'll start getting all kinds of error messages from Git. And that's one place where things get interesting. But this is a good excuse to sort of play with this if you like. And my recommendation would be, you know, get in the habit of, before you start pulling down changes that your other team members have made, make a local backup of your code, right? Just make a directory somewhere outside of this repository. And if, you know, you've got some piece of code that's really critical, just copy it somewhere else before you do this git pull. Because things can happen, like, you know, your team member might decide they don't need this file that you're working on, and they might remove it and then push their changes. Well, if you do that pull is going to delete the file from your repository. Now you can go back and get it through Git, but if you just make a copy of it somewhere else, you've still got the code, and then you can talk to your group mate and say, hey, why'd you delete this file? And that kind of stuff. This is a nicer project to go through these learning experiences on than some kind of big, you know, sort of final project for a capstone or something at a university. So if you want to play with Git, I encourage it. And if you want help with how to do some of these things, come by office hours and we can actually go through some of these commands and go through some scenarios and stuff. Or if you do this and things get wonky, let me know and I can help you untangle them. All right, so any questions at this point on PA5?
I just have a random question.
Okay,
And you might have said this, but I thought I'd ask anyway. So when it comes to pushing the program to PA5, I know that you said that if we all pushed it, everybody except for one person would have to have a do not grade file.
right.
Is that mandatory, or can we just literally have the one push it or one person push it and then no one else pushes anything, like at all?
That's your best way to do it,
Okay, cool.
is just
Okay.
have one repository. Yeah, I mean, that would be the ideal.
And then I take it like all of our names are on there. So like if I, teamed up with like Matthew and he just pushed it and my PA5 just was non-existent, I'd be good.
Yeah, so
Okay.
as long as in the beginning of each bash file, there's the comment block with the full name of each member, that's what I'm going to look at.
Okay, cool. Thank you.
Yeah, you're welcome. All right, so I'm gonna add the missing parts of this required presentation to say, you should show deleting an appointment and so on, and I'll re-upload this later on today. But other than that, this should be good. All right, so let's take a 5-minute break. And when we come back, let's start talking more about Bash itself and dig into some more Bash tricks that will be helpful in PA5, but also in general. Yeah, you can just VI do not grade and just put a dot in it or something. All right, so I'll see you back in about 5 minutes. All right, welcome back. So a couple of things in Bash that I wanted to mention that may be useful in PA5. So you're going to make a file, probably under /temp, that's going to store your appointments, and can, you know, have something like date, appointment, date, appointment, and so on. And you may want to, you know, display all the appointments on a certain date and maybe display them one at a time. So you'd like to go through this file and, you know, find each line where the date matches some particular pattern. And if that's the case, take the appointment part and throw that up in a message box so that the person can see it, and then have a button that says next, and they can click next and go on to the next appointment. And so if this is sitting in a file, we'd like to be able to run through this file one line at a time inside a Bash script. And it's pretty easy to do. So here's a sample file. So this is the text of War and Peace. And inside Bash, we can process this file as follows. So let's write a main program. And we can use the following syntax. We can say while read line do, and then we can put in some body of our do loop. And at the end, we can say done less than and the name of a file. And here's what's going to happen when Bash sees a construct like this. It's going to read the first line from this file, so everything up to the first new line, and it's going to take what it reads and store it in this variable called line. And then it's going to execute whatever's in the body of the loop. And then at the end of the loop, it's going to go back to the top and read the second line of this file and store that in this same variable, execute the body of the loop. And it'll keep doing this until it gets to the end of the file, and then my while loop will exit. And so this is a while loop that you're totally allowed to use. And so I'm just going to make the body of the loop something like, you know, next line is $line. And so if I run this, right, it just reads that file as input and runs the body of my loop for each line that it reads. And so maybe I want to add, you know, line numbers to the front of each line. So I could say, you know, number equals 0. And I could say echo quote $number $line. And then I can set number equal to $number +1. And if I run this, I've got, you know, copy of my file, but with line numbers added to the front. And this is just a different type of while statement. It's not a condition, so we don't have the double square brackets around it. It's a totally different type of statement that happens to start with the same word while, but it's really got its own syntax. And then the other useful type of loop we can do is we can actually say done 3 less than signs, and then inside back quotes we can put a command. And so maybe I want to do you know, an ls command. And so same idea, this while loop will execute this command, and each line of output that this command generates will cause another iteration through the loop. And each of those iterations, this variable line will be set equal to that line of output. And so here's what's in my directory right now. So if I say main, it showed me, well, that was kind of goofy. Let me do an ls-l. Hold on a sec. Well, that's unfortunate. So anyway, so it's pulling in the whole line. The whole output is a single line. All right, that's a little wonky. But anyway, that's another option. The other thing you can do is you can say some command. So for example, I can say let's run the BC command, and I can say BC less than, and I can put in some label that I want, right? I'll just call it tag. And basically anything I put between this statement and a line that begins with just that same label will be fed as input to whatever this program is. So BC is this calculator program that, you know, you can just type arithmetic expressions and it will evaluate them and print them out. So I could type in, you know, a series of expressions. And this chunk of code will execute BC, and it will give it these 4 lines of input. And we'll see each corresponding output generated. And let me just throw some markers around here. So I'll say ready to run the BC command. And then we'll say finish running BC. So if I run this program, right, it says ready to run the BC command, and then it executed those 4 statements. And then it said finish running BC. So this can be useful if there's some command you want to run that takes multiple lines of input. It can also be useful if you wanted to, you know, display a bunch of information. I could run the cat command. And all of this should be taken as input to cat. And so my script should print out all of these highlighted lines in as it executes. So that's useful sometimes. So those 3 options. So done less than file, or done triple less than back quote command, or command double less than tag, and bunch of input, and then a line that's got that tag on it. And the only magic words here are, you know, like while, read, do, and done. So it doesn't have to be while, read, line. It can be any variable name. It doesn't have to be tag. It could be any reasonable label to mark the end of the input and so on. And so those might be useful when you're, you know, for example, trying to break up your appointment calendar and read your file one line at a time. All right, so on Canvas, there's a page labeled regex summary. And this is just kind of a half-page synopsis of what we started on Tuesday with regular expressions. And we haven't gone through all of this yet, but quick reminder, basically a period is a wild card, matches any character. A star can be placed after something, and it'll match 0 or more occurrences of whatever that something is right before the asterisk. A caret and a $sign are called anchors, and they say we want to match some pattern beginning at the start of a line or ending at the end of a line. Most characters are just, you know, a character that we want to match, but there's some special characters like, you know, period and asterisk and caret. A set of characters inside square brackets will match any of those. If we put a caret in the beginning of that, it'll say match anything except those. And we started playing around with this in VI. And in VI, we could say colon s/old/new to replace this pattern on a line with this pattern. And we can also put in 2 line numbers separated by a comma and say, do the substitution everywhere between this line and that line. And a $sign is the same as whatever the last line number of a file is. So if we say :1, $, that says do the substitution on every line of the file. So let's go into our data file here. And, you know, I can search for the word war. And there's worn, there's war, and so on. And if I say : substitute war with uppercase war, then that occurrence of the pattern WAR gets replaced. And if I say substitute letter E with an uppercase letter E, or with 3 uppercase E's, right? So this E got replaced with 3 uppercase E's. But notice this E didn't change, this E didn't change, and so on. And so in these substitute commands, we can also put a G after that last slash, and that says replace all occurrences of old with new on this line. So it makes it global across the line. So sitting on this line here, if I say : substitute E with 3 uppercase E's / G, now each of those lowercase e's gets changed. All right, and we started talking a little bit about grep, and grep was a command that understands regular expressions. And we can say grep pattern and a file name and search for that pattern in the file. So if we say grep war data, that shows us every line in the file containing the pattern WAR, which also includes, you know, the word toward or reward, as well as lines that actually contain the word war. And so if we wanted to find the word war, but not the word worn, right? We could do something like grep WAR followed by a space inside our file. And now we're only picking up, you know, things that contain war followed by a space. Now, why did I have to use quotation marks? Because if I do this, those extra spaces are not part of this pattern. Those spaces are just a delimiter between this argument and that argument. And so if I want to actually include that space as part of this second argument, it's got to be inside quotation marks. And if I wanted to find instances where the word war appears in the beginning of a line, I could put a caret there. And now I'm just finding all the lines where war is the first word. All right, so if I want to search for a digit, I could use this kind of notation. And in addition to saying something like bracket A, B, C, I can also use dashes like bracket A dash Z to search for any letter between A and Z, or bracket 0-9 to search for any of these digits. So if I say something like grep 0 through 9, that'll show me every line of this file that contains a number anywhere. If I wanted to find 2-digit numbers, I could do this. Search for 0 through 9, 0 through 9. I'm using quotation marks here because brackets might have special meaning to bash. We know that we use brackets for if statements, for example. So I'm just putting quotes around here to eliminate any possibility that bash is going to see this as anything other than a character, and a character. And so that pulls up any line of the file that has at least 2 digits in a row. And I did this in class yesterday and stumbled across this in the middle of War and Peace, which is, you know, a very old novel. And sure enough, in the middle of this history of war, there's this paragraph that does a little algebra. And it's not just an Easter egg. Somebody else looked it up, and I looked this up on the archive site. And yeah, this is actually in the text of the novel. So yay for algebra. All right, so we already played with regular expressions for searching, and that's fairly useful, but we can also use regular expressions to do editing on a file. And so when we say substitute old / new, this can be a regular expression, so it can have wildcards and things in brackets and so on and so forth. But this thing we want to replace the old with can be more complex than just a fixed pattern of characters. It can be a pattern that includes information about what we match in this old part of the search substitute command. So what do I mean here? Let's make a simple file called names. All right, so here's a random file of random names. And suppose I want to change each of these first names into just a first initial. Sorry, Scott. Suppose I want to change these first names into just a first initial. So I want J Cool, N Macias, I Horme, S Cos, and so on. We can do this with a single VI command. And this is built on the idea of regular expressions. So here's the idea. We're going to start with a name like Nick Macias. So to do this kind of substitution, it's a little bit of a puzzle solving game, right? We need to think about how do we identify this thing that we want to replace, and then how do we describe what we want to replace it with. So to identify this first name, I could simply search for something that begins at the start of the line. And then I could say any number of occurrences of period, right? So any set of characters followed by a space. So if I go into my file and I search for that pattern, let's start at the beginning. Let's say search for the beginning of a line followed by any number of characters followed by a space. It takes me to the name Nick. If I hit an N to search again, it takes me to this line and then Scott and Tina and Carol. And then back up to the beginning. Now, if I come up here, that matches, JOE followed by a space. Oh, I've got it anchored at the beginning. Never mind. All right. So this pattern will match the first name. And if I said something like, substitute beginning followed by any number of characters followed by a space, replace that with nothing, that'll just get rid of all the first names. If I said take the beginning of the line followed by any number of characters followed by a space and replace that with, an X followed by a period and a dot, that'll change each of these first names into the initial X. Well, what I want to do is change this first name into a J, the second one into an N, the third one into an I, and so on. So I'm going to modify this pattern a little, and this is going to be the next piece of regular expressions, something we call registers. So I'm going to say, hey, let's start at the beginning of a line, and let's match any one character, followed by any number of characters, followed by a space. It's going to match the same thing. This is going to match the letter J, and this would be OE. Or on the next line, this would be the letter N, this would be ICK. But now this is matching the thing that I want to save in my output. Well, thank you. So here's what we can do with regular expressions. We can throw parentheses around a pattern, and whatever matches that pattern is going to get saved into an area that we can read from. So for example, parentheses around this dot says, hey, whatever matches this dot, which would be the first initial, let's put that into what's called a register. So this will go into register 1 because it's the first set of parentheses. And we can read register 1 by saying \1. So I'm going to substitute beginning of the line, period, followed by any number of characters, followed by a space, with whatever went into register 1, which is just \1, followed by a period, followed by a space. And that's going to take this whole first name, NICK, and replace it with an N, a period, and a space.
Whatever you're pointing at is behind the terminal.
There we go. Thank you. All right, so match the first character, put that into register 1, match any set of characters followed by a space. That'll be all of this. Replace that with the contents of register 1, which is our first initial, a period, and a space. And just to make it even more confusing, when we use parentheses, We have to escape them with backslashes, otherwise it will look for a literal parenthesis. All right, so what does this look like? Substitute beginning of the line. Let's put in a parentheses and a period and a close paren. So that says take the first character of the line, put that into register 1, and then any number of characters followed by a space, and replace that with register 1 followed by a period followed by a space. And that's going to replace each of those first names by a first initial. So that's what this business is. All right, so disclaimer up front, these are extremely difficult to read. They're not that hard to write though. Once you get a little bit of experience writing regular expressions, coming up with something like this is pretty easy. Nobody memorizes these and nobody reads these if they don't absolutely have to. But you can learn to write these, and it's like, you know, I don't know, it's kind of like writing assembly language. It's usually easier to write than read. But the whole exercise comes down to thinking in terms of what you want to do as a pair of operations. I have to match some part of my string, and then I have to replace what I matched with something else. And if we think about problems from that perspective, there's a lot that we can do with these simple substitution commands. So for example, when I set up accounts in the beginning of the school year, I go to Canvas, I pull down a list of student names, and they come in as first name space last name, or maybe last name comma space first name. And I need to change those into what are going to be your account names, which is first initial followed by last name. Right? I don't do that by hand. I do that with a few of these substitute commands in VI. $1, so if you say line 1, line 2, it applies this substitution on all the lines between line 1 and line 2. So the 1 is saying starting with the first line, and $sign means the last line. So $1, means do this everywhere in the file on every line. You can also use period to mean the current line, and you can do like, you know, period -5 to say 5 lines before the current line, and so on. So you can do arithmetic. So yeah, that's basically saying take the first name and return it as an initial. But let's do some more examples of this. So suppose I want to change something like Nick Macias into Macias, comma, space, Nick.
It's behind the terminal again.
Thank you. All right, so I want to make this transformation. So if I can match this and put those in registers, if I can put this in register 1 and this in register 2, I can replace the entire line with \2, \1. So what would this look like? Beginning of the line, parentheses, any number of characters, followed by a space, followed by any number of characters, followed by the end of the line. And I'm going to replace that with \2, space, \1. So I'll go :1, $, substitute beginning of the line. Something like that. And so there's that modification. And you know, I can have 10,000 lines in my file, and it's one line of this regular expression substitute that I type into VI, and it makes this change everywhere in my file. And so this is another dimension in which, you know, using an editor like VI unlocks a lot of potential, because, you know, trying to do this some other way, I mean, I can delete this and I can go to the end and I can add a comma and then I can do a put, and I can do that on every line, but that's kind of a pain. So other ways to do this. So we can't do this with grep because grep is only for searching. But we can do this with another command called sed. And so sed is the stream editor. And we can say something like sed single quote substitute old new. We can put a replacement command in here and then put in a file name. And so I could say something like change the occurrence of E to 3 uppercase E's everywhere on a line on my names file, and it shows me the output of applying that edit command everywhere in my file. And so if I want to do some of these things we were just playing with, substitute beginning of the line, a single period followed by any number of characters, followed by a space, followed by a single character, followed by any number of characters, followed by the end of the line. And let's replace that with the first initial followed by a period, a space, and the second initial followed by a period. And let's do that on the names file. And so now we've reduced it to, you know, a set of pairs of initials. So the only way to learn these things is to play with them. And, you know, you can stare at this and try to figure out what this does. And there may be some limited value in that, but it's much more valuable to take, you know, this summary and start trying to do some of these things to a sample input file. And I've got some exercises posted that we'll look at in a minute also. This does not change the file itself. This is just saying read from this file and display the output on standard out. And if you don't name a file, then it just reads from standard in and applies the changes on that. And so I could, you know, also cat the names file and pipe it into that sed command, and it'll get standard in from the output of this command, which, you know, is just displaying the contents of that file. So if I wanted to actually change the file, I could run that command, but put the output into something like names2. And now if I look at names2, it's got the changes in it. So a different approach would be if I wanted to actually edit the names file first, copy names into some sort of backup file, and then run your sed command on the backup file and put the output back into names. And now names itself has been edited. And so that's probably the approach you want in PA5. And the advantage of that is that you end up with a backup. So if something goes wrong, if somebody, like, you know, interrupted the program partway through this, you can always go back to the original file and, you know, get that back. And if you try to do this, you get sadness because your file gets truncated when bash sees you're going to write to it, and then there's no data to process. All right, so one thing you might find is that, if you're going to build an appointment file and you're going to use something like, date followed by a description of the appointment. If your description contains spaces, remember Bash treats spaces differently sometimes. If I have a variable and it contains a string that has a bunch of spaces, there's some things I might try to do to that variable that are not going to work correctly. Those spaces might trip me up. And so I could do something like this. I could say sed substitute space with underscore everywhere. And then if you have a line in your appointment file with spaces, it gets changed into a line without any spaces. I just change those to underscores. And then if I want to undo that, I could say, replace underscores with spaces. And now if I type in that line that had the underscores, I can change it back into the line that looks human readable. So sed is just kind of a general workhorse tool, and you can do some very simple things like this, or some fairly sophisticated things like that. And it's a good go-to as you're manipulating strings inside Bash for doing some fairly powerful modifications. So in addition to this regular expression summary, there's a regex practice question section. And these are some exercises you can just kind of try on your own. So the first ones are kind of getting our feet wet. So remove the first occurrence of the letter Q from a line. So if you do something like substitute Q with nothing, right? That'll look for the first occurrence of the letter Q and replace it. Removing all Q's from a line, well, go ahead and throw your global switch at the end. And that says, hey, do the substitution as many places as you can on the line. And then these are similar difficulty, but deal with these anchors. And then we get into the registers. And so you'll remove the first three and last three characters from a line, swap the first two characters. So how could we swap the first two characters of each line if we have an A, B, C, and we want to swap these? What sort of regular expression could we try to cobble together? Any ideas? So there's a string. How can we match the first character on a line?
With the parenthesis like period, is that right?
Yeah, so do parentheses with a period. We can put an anchor in the beginning. Now regular expressions always start from the beginning. So the anchor doesn't actually do anything here, but I'll just put it in out of habit. So this will match that H. And then how do we match the second character?
We could do the same thing.
Do the same thing. And so if we say substitute this with, well, this is going to go into register 2. This is going to go into register 1. And so that'll replace the first two characters with the second character followed by the first character. So if I say HELLO, it swaps those first two. And Control D gets you out of sed like everything else.
So just for clarity, so we're escaping the parentheses, or else it'll start looking for actual parentheses.
Correct.
And you're escaping, like, so like at the first half of this, you're putting in angle brackets, and then the dude, I look at them like little dudes with arms. They're telling you which ones to pick, and then so every time we do like an action, we want it to be in like these like forward slashes. Is that right?
So this is delimiting the old from the new.
Okay, I see I see. That
Right.
makes
So
sense.
it's generally substitute old, new.
Okay, yeah, I saw that on
And-
Canvas. I just wasn't putting it together, I guess.
Okay. And if we don't do the escapes on the parentheses, this is a lot easier to read. Right. Just substitute the first two any things that we match with the second thing followed by the first thing. But bash or regular expressions need those escapes. And these slashes don't have to be slashes. We could say, for example, substitute number sign old, number sign new. And this first number sign says, hey, that's what I'm using to separate the old from the new. And I can use more or less any reasonable character that I want.
Can you use those like straight lines we used for sticks? So that
Yeah.
you can, sweet.
And that's particularly useful if my pattern that I'm looking for is something like a path name. So if I want to replace, /user with /user/bin. Well, if I do s/, then I've got to escape all of these slashes and so on. So I would just do, substitute number this thing with that thing. So that can be a little more convenient. And there's websites out there that will let you play around with these. Just look at regex calculator or something, and you'll find websites where you can type in a string and type in a regular expression, and as you type it, it will show you what's being matched and what the contents of the registers are, and so on and so forth. And so yeah, in the case of the initials, I had a new pattern of \2 period. That was just a period. So I think I was printing initials. So I wanted to take the contents of register 2 and follow it by a period. So it's just a literal character. So take a look at some of these, talk about them, kick them around, see what you can come up with, and ask questions next time. And these are good exercises. And you're not going to be tested heavily on this, if at all. But if you can get this into your bag of tricks, it is really, really valuable. Unix is so sort of file oriented, and if you're doing any kind of spending any amount of time in a Unix environment, you'll just start encountering lots of situations where a regular expression will kind of save your day. Whether it's editing code and I need to comment out every spot where I did this, or I need to change a variable name, but I need to do it somewhat intelligently, or I need to, make some change on my comments or something. Regular expressions will come to the rescue a lot. And don't try to memorize them, right? And don't try too hard to read them. Practice writing them. And start with the simpler types of things, just straight replacements, anchored replacements, and then start playing around with putting things into registers and using that to do some different things. And while we're at it, So let's find one character. And then any number of characters followed by the end of the line. And let's replace it with the rest of the line followed by the first character. And there's, ODP 418. And it works fine on empty lines, and it works fine on lines with a single character. And it works fine in the general case. So we can write C code and debug it and worry about edge cases and all that kind of stuff. But again, it's just a single sed statement to do that same behavior. Take the first character and move it to the last position on the line. And if we
So
have,
correct me if
line, go ahead.
Yeah, so correct me if I'm wrong, but is sed basically like the main way you interact with strings in Bash?
No, but it's one of them.
Okay.
There's also awk, AWK, and that does a different sort of thing. And we can do a lot of what we do with sed with awk and vice versa, but sed is really geared towards making changes on a line by line basis. And sometimes we have a file where each line contains a number of fields, for example, a comma separated file. And we might want to do things to each individual field, and that's where something like awk comes in. But sed will definitely be a very popular utility for processing strings in Bash. And if I have a string that I've stored in a variable, like for example, this variable line, I can echo that and I can pipe it into this sed command. And it will run this stream editing command on whatever the value of this variable is. And I can say something like new line equals back quote, all of that stuff. And I can store the result into a new variable. So if I read a line, I could then take it and echo it and pipe the output of echo into sed and capture the result of all of that and save it in a new variable. And again, basically one line of Bash that does, quite a bit of processing. All right. We have class on Tuesday and Thursday next week. We have class on Tuesday the following week. Thursday is a holiday. And then the final week, Tuesday and Thursday, we're using for presentations on PA5. So we really have 3 lectures left as far as new material in this course. So we'll wrap up regular expressions on Tuesday. And then I want to talk about processes. And I want to talk about profiling code with gprof. I want to talk about awk. And look at curl for grabbing web pages and a few other things like that. But we're pretty much coming to the end of the course. I mean, in 3 more lectures, so about 6 hours of lectures, and then we're kind of done. So we're making good progress, and the end will come quickly. So get PA4 turned in by tomorrow morning, and figure out who you want to work with on PA5 and get started on that when you can. Hope everybody has a great weekend. Tomorrow is a school holiday, so no classes. So I will see everybody next week. Have a good one. Thanks.
Bye.
Bye.